Hi everyone. So today we will be discussing the IAL Pure Mathematics, the P3 paper, the June 2021 paper actually. Okay. So let's start off with the first question. The curve C has equation y equal x square cos half x. The curve has a stationary point at the point P. Show using calculus that the x coordinate of P is a solution of the equation. Okay, 2 arctan 4 over x. Okay. So it's about, they're talking about a stationary point. So what do you mean by a stationary point? Obviously at a stationary point, or in other words, a turning point, the gradient, the dy by dx term will be set to 0. It will be equal to 0. So all you got to do here is, all you got to do in the first question, part A, is to make your y equal x square cos half x. So you got to make it, you got to find dy by dx first. So how do we find dy by dx? As you can see here, we have a product, isn't it? So x square multiplied by cos half x. So when there's a product, obviously we'll have to use the product rule. So product rule, how does it go? In the product rule, so one person stays while the other person differentiates. So for example, x square stays while cos half x differentiates. So cos half x differentiation is negative sine half x. Then into, you have another half, isn't it? So cos differentiation is negative sign, you write the angle as it is, and then into differentiation of the inside. So it's a chain rule. Then after you're done with the cos half x differentiation, you put a plus. And now it's time to keep the cos half x waiting. So now the cos half x waits while the x square differentiates. So x square differentiation is 2x. So this is what we call as the product rule. So when you have two products of 2x functions, one person differentiates while the other person waits. Okay, so x square waits, cos half differentiates, plus the cos half waits now while the x square differentiates. So okay, we got our dy by dx. Let's just simplify it a little bit, make it equal to 0 and try to get this, show that. So it's 4 marks. So dy by dx equals, let me try to simplify this. So this is negative x square over 2 sine half x plus 2x cos half x. Okay, and then you make your dy by dx, you set it to 0 at the turning point. And you end up, so you need to now, simplify this. So I will take the negative term minus the term to the other side as a plus term, plus x square over 2 sine half x equal to 2x times cos half x. So now, so if I look at the show that, so I can see it's arctan, meaning I have something to do with tan here, isn't it? So we have something to do with tan here. So I can see that there is a sine half x and there's a cos half x. So we know sine over cos gives us the tan. So let's remove the other terms. Like I'll keep the sine and the cos terms on this side, while all the other, the x square, the 2, I'll try to take it to the right hand side. So I end up getting here rearranging sine half x. I'll bring the cos half x to this side as a division over cos half x. Okay, sine half x over cos half x equals, on this side you have 2x or into 2 over x square. 2x into 2 over x square. So sine half x over cos half x gives you tan half x. So x and x cancels. So actually 1x is remain down. 2 times 2, 4 over x. So we get here tan half x equals to 4 over x. So we are kind of close to our answer now. Now what do we do? Obviously we go for tan inverse. So tan inverse is what we also say as arctan. So tan half x equals 4 over x. So half x equals tan inverse 4 over x. So tan inverse is what we also refer to as arctan. So arctan 4 over x, and then you take the you make x a subject, isn't it? So this 2 division by 2 goes to the other side as a multiplication. So x equals to 2 arctan 4 over x. Okay, so that is the answer for part A. Okay, so moving on to part B. Using the iteration formula xn plus 1 equal to arctan 4 over xn, find the value of x2 and the value of x6, giving an answer to 3dp. Okay, so what do we do here? We have the iterative formula xn plus 1 equal 2 times arctan 4 over xn. So iterative formula, it's quite easy what you need to do here. So first we have x1. So you need to put n is 1 and you get here x1 plus 1 is x2 equal to 2 arctan 4 over x1, isn't it? So it's actually quite easy. You really don't, I mean, you know, in iterative formula, so you put the x1 value here, and you put 2 here, you get the answer. I mean, get the answer for the whole thing and get x2. Then after you get x2, I mean, you need to go on till x6. So you have to put the x2 value again over here and you get x3. The x3 value we should again replace over here, you get x4, isn't it? So that's the iterative formula. So let me do it in the cal. What I do here is the easiest way to do this is, first thing, make sure your cal is in radian mode, because our sum, you can see x is in radians. So make sure the cal is in the correct mode, and then you type the equation 2 arctan. So that's going to be tan inverse 2 arctan 4 over, I'm giving it in the general term in terms of x. So I get here 2 arctan, or that is 2 tan inverse 4 over x. I give this. Okay, and then what I do is I give calculate and give the first x value, which is x equal to. So give the first x value of x equal to, and I get the first answer. This is the x2 answer. x1 is 2. So x2 equals to, what was the figure that we had? x2 equals 2.214. So they wanted to 3 dp. So 2.214. It's correct to 3 dp, right? Yeah. So 2.214. That's correct to 2.21, correct to 3 dB. So we need to find x6 as well. So I need to continue. So x3. So x3 will be 2 arctan 4 over x2, isn't it? So then what I go is, what I do is I take the cal, and then I press again calculate. I mean, we need to give the x value here. So don't give x as 2.214. Obviously, you should know that. You give cal, and for x you give the answer. The big decimal answer for x2 is stored in your cal. So give answer, x equal answer, and then it puts the whole value. So here I have x3 correct to 3 dp. It will be 2.130. So that will be 2.130. So I need to continue. x4 will be 2 arctan 4 over x3. So let me again take the cal. So it's really easy. All you got to do is the x3 answer is stored in the cal. This is x3. So you give cal and give the answer here for x, and then it inputs the x3 value for x, and then you get the next answer 2.1628, which is 2.163. 2.163, and then moving on, x5 2 arctan 4 over x4. So when I take the value again from the cal, so again you give calculate, give the x as the answer, and you get 2.150. So finally, x6 is it's the thing that they want us to find. So x6 equals to 2 arctan 4 over x5. So that gives me calculate x equals answer, and you get, so this is the final answer 2.155. So this answer must be you cannot, the decimal places are not relaxed. It must be 2.155. Not a single decimal place can be changed. Okay, so it's really important that when you're finding this x2, x3, x4, that you input that whole decimal, the whole bunch of values should be replaced. Now the x2, x2 is not just 2.214. There were a lot more decimals here. So all of those decimals, that huge value only you substitute for x2 when you find x3, not just the 2.214. Otherwise, you will lose the significance, and by the time you come to x6, your answer will be truly deviated from the proper answer. So here there are no approximations, because I have been inputting the exact value into my x. Okay, so this is the answer. So x6 must be 2.155. Okay. Okay, moving on to question number 2. Show that 1 minus cos 2x over 2 sin 2x is equivalent to k tan x. So it's a identity sign, isn't it? So that means you need to take one side, either the left-hand side. So I think best to take the left-hand side here, simplify, and try to get the right-hand side. So let's start. Question number 2, part A. 1 minus cos 2x over 2 sin 2x. Okay, so equivalent to k tan x. So let me work with the left hand side. As you can see, so we have some double angles here, so 2x, and you can see the answer has just simply it just has the x. So that means some double angle rules are involved here. So let's work with them. So 1 minus cos 2x over 2 sine 2x. So as you all know, if I show you, yeah. So these are the double angle rules, right? So I just highlight it here. Yeah, so you can see for sine 2x or sine 2a, we have one formula, 2 sine a cos a, while for cos 2x, we actually have three equations that we can use. Cos square minus sine square, 2 cos square minus 1, and 1 minus 2 sine square. So actually what I need to do here is I'd like to put here, I'd like to use the formula for cos 2x since there are three candidates. The best one to use here would be the one that could get rid of this 1 for us. So if I use 2 cos square a minus 1, so bear in mind that there's a negative sign in front. So I think it would make this negative 1 positive, so it will not cancel off the 1. So the best person to use here would be 1 minus 2 sine square x. So cos 2x equals to 1 minus 2 sine square x, right? So let's substitute that for cos 2x, and for sine 2x, we have 2 sine x cos x, okay? So be careful here, 1 minus, replacing the cos 2x with 1 minus 2 sine square x over. So remember there is a 2 here. Now many people would confuse this 2 along with this 2, and they'll just be writing a single 2 here. So that's wrong. So this 2 was what you had over here. That 2 was already there. Okay, so it was already there. While sine 2x is going to give you 2 sine x cos x. So that is something else that comes separately. So sine 2x is 2 sine x cos x. So please be aware of that. Sine 2x is 2 sine x cos x, which has these two separately. Right, so then we get here 1 minus 1, that's so 1, okay, let me write minus 1 plus 2 sine square x. 2 times 2, 4 sine x cos x, right? So as you can see here, the 1 and 1 will cancel off. 2 sine square x over 4 sine x cos x. So 2 times 1 is 2, 2 times 2 is 4. I can cancel off a single sine term. So I end up getting here half. So the half is down, and you have sine x over cos x, which gives you half tan x. So this is the answer for part A. So k equals to half. Okay, so k equals to half. So moving on to part B, hence solve for. Hence, as you know, whenever you see the word hence, it means to use the help of part A. So hence solve for theta between 0 to 90 degrees. So range is in degrees. So bear those things in mind. Solve for theta between 0 to 90 degree. 9 times 1 minus cos 2 theta over 2 sin 2 theta equal to sec square theta. Okay. So obviously what we need to do here is they use the word hence, which means we definitely need to use the help of part A, and we can directly see some kind of relationship here. I think I can see 1 minus cos 2x over 2 sin 2x, like it's entirely there over here. I mean, like we can see the whole thing is there, the whole chunk is there over here, except that there's a extra 9. So however, all you got to do is simply to replace. Okay, so you got to simply replace. Okay, so let's replace. So moving on to part B. So 9 times 1 minus cos 2 theta over 2 sin 2 theta equal to sec square. So you're supposed to solve. Solve means obviously you need to find the value of theta, isn't it? So then as you can see, these two sums are like, they are almost identical, just that the x is replaced by theta. So all you got to do is in your answer k tan x, also the x should be replaced by theta. So I think we found the answer here. This is equal to half tan x, right? So that means in this situation, it will be equal to half tan. It will be equal to half tan theta, isn't it? Just the x replaced by theta. So half tan theta equals to sec square theta. Okay, so I kind of get something like this: 9 tan theta over 2 equal to sec square. So what I'll do is I don't want to work with decimals. I'll bring this 2 to the other side as a multiplication. I end up getting 4 sec square theta. So the question is to solve. So if you're trying to solve this, you need to make everything into one type of you need to make it into a single type of trigonometric function. That means it should be either fully cos, or it should be either fully tan, or it should be fully sine. So I have a tan and I have a sec square here. So that doesn't work. I need to convert it. So we need to think of an identity here who can which can convert. Okay, so we know sec square is 1 over cos square, but I don't think using that is going to be very helpful here. We have a easier rule that we could use. What is that? So the identity 1 plus tan square. 1 plus tan square theta equal sec square theta. So this would help us, isn't it? Why? So I can replace the sec square with 1 plus tan square. So I could use that here and I could get my entire equation here in terms of tan. So let me substitute. So 9 tan theta. So I'm going to substitute this. So let's put the value 9 tan theta equal 4 times, replacing the sec square with, make sure you put brackets, 1 plus tan square theta. Okay, so we end up getting 9 tan theta. 4 into 1 is 4 plus 4 tan square theta. So taking everything to one side, I end up getting here 4 tan square theta minus 9 tan theta plus 4, right? 4 tan square theta minus 9 tan theta plus 4. Okay, so what's the next step? The next step is to, you need to, solve this quadratic equation. So I think we'll have to, it does not factorize, right? So you'll have to either use the formula or you just need to, quickly factorize. So tan theta equal minus b. So minus b is minus 9 plus or minus b square minus 9 square. 4 into a is 4, c is 4, isn't it? Divide by 2 times a is 4. So I could, you could just type it in the cal as well. Then equation number 3, ax square bx plus c. A is 4, b is minus 9, c is plus 4. Okay, so then I end up getting here 9 plus root 17 over 8 and 9 minus root 17 over 8. So let's write it. Tan theta equal 9 plus root 17 over 8, or tan theta equals 9 minus root 17 over 8. Okay, so we need to solve this now. And they have given us the range only from 0 to 90. So actually only the first quadrant, isn't it? We only need to take the first quadrant. So actually if I take the value here, 9 plus root 17 over 8, because we need to check the quadrant which it is in. 9 plus root 17 over 8 is a positive figure, isn't it? It's 9 plus root 17 over 8 is 1.640388. 1.640388. So I'm just taking a few extra decimals here. So I need the first quadrant. Normally we draw all silver teacups and we choose the quadrants where here tan is positive. So we would choose all and tan. So we would normally mark, we mark these two angles, but you can see in this situation, since our theta, they've told us that theta is only between 0 and 90, we really don't need to go to this quadrant. Okay, so the first quadrant is enough. So taking, we need to take the tan inverse of this value, then we are done. Let me take the other side also before I take the tan inverse. So this is going to be tan theta equals 9 minus root 17 over 2. That gives me 9 minus root 17 over 8. So that gives me a 0.6096118. 0.6096118. So I just took a few extra decimals. 6118. Okay. So that's a positive figure again. So which is a positive figure again. So again, all silver teacups, and you choose the quadrants where tan is positive. So it's this guy. So the other guy, I don't need it because it's jumping the range of 90. So I need to just mark this angle. So let's get it done. So calculator needs to be in the degree mode. Calculator needs to be in the degree mode. So make sure it's degree because our angles are supposed to be in degrees. So the first one is going to be tan inverse 1.640388. That's the reason I took the decimal here. You might be wondering, can't we just take tan inverse of this 9 plus root 17 over 8? Obviously you can. So I was just, here, of course, there's no issue because we know it's surely positive. But in here, I was wanting to double check whether this figure was a positive or a negative figure. Because in an event, if this was negative, I need to mark the quadrants where tan is negative, which is sine and cos. So taking the decimal term, when you have a negative figure, when you have a negative sign to be, when you have a negative sign visible, it's advisable to, check the decimal figure to make sure whether it's a positive figure or negative. Because if it was negative, I would have to choose a sine and cos quadrants. And in that situation, we are getting solutions outside of our range 0 to 90. So that in that particular situation, if this was a negative figure, then we wouldn't have got answers for this particular range. So it's important. That's why I took decimals, and I took a few extra decimals just to make sure that I will not lose my significance. Okay, so I just want the answer to how many decimals here? They want the answer to 1 decimal. So I've taken a lot, so then we will not lose our significance, so nothing to worry. So tan inverse 1.640388, that gives me the first answer 58.6. Correct to 1 dp, 58.6. The first answer for theta is 58.6. The second answer, this was the 58.6. We only have one answer. The second answer is tan inverse 0.60961118, which gives me 31.366, which means 31.4. So 31.4. So these are the two angles. So these are the two angles, the two solutions in this particular range. Okay. Okay, so let's move on to question number 3. Integration of 12 over 2x minus 1 square, giving you answer in the simplest form. Okay, so if I give you the idea of how to integrate this, so the rule that I'll be using here is the integration of ax plus b to the power n. So just to give you an idea, so this is the rule that I'll be using. The integration of ax plus b to the power n is 1 over a times ax plus b to the power n plus 1 divided by n plus 1 plus c, right? So this is the formula that we will be using, the first integration rule. So here I have 12 over 2x minus 1 square, integrating with respect to x. So first what we do is, we rearrange the whole thing. So 12 is a constant which you can bring out of the integration sign. So then the 2x minus 1 square, I'm going to take it up as 2x minus 1, to the power of minus 2. So I brought it up, the positive power becomes negative. So now I'm going to use my integration rule. So as you can see, ax plus b to the power n, 2x minus 1 to the power minus 2. So you can see the a, b and n figures here. So all you got to do is to apply to this equation, the basic integration rule in your P3 book. So 12 times 1 over a, it's going to be 1 over 2 times 2x minus 1 to the power, you add 1 to the power minus 2 plus 1 is minus 1, isn't it? Divide by minus 2 plus 1, which is minus 1 plus c. So rearrange the whole thing nicely. So when you rearrange it in an orderly way, the negative sign comes from 12 over 2, that's a 6. And you get 2x minus 1 to the power minus 1 plus c. So if I arrange it a little bit more, I get minus 6 over 2x minus 1. The power negative 1, I brought it down and it became 2x minus 1 to the power plus 1, right? This is the answer for Roman number 1, 2 marks. Okay, then moving on to part Roman number 2, part A, right? 4x plus 3 over x plus 2 in the form, okay. So 4x plus 3 over x plus 2 should be written in the form a plus b over x plus 2. So you could do this in several, there are many ways of doing this. So either you could, you could divide, or you could, just compare coefficients, take this x plus 2 to the other side and get the AB values. So I think I'll take the x plus 2 to the other side and get the AB values. I'll show you another way also. There's another a simple trick to get this as well. So b over x plus 2 times x plus 2, isn't it? So I brought this denominator x plus 2 to the other side. It multiplies with a and it multiplies with b over x plus 2. So what happens is, what happens here is with b over x plus 2, the x plus 2 that we brought from the other side will cancel out. So you end up getting 4x plus 3 equal a times x plus 2 plus b. So now it's a matter of putting a few x values and getting our answer, or you can compare coefficients, up to you all. So I'll put when x is minus 2. As you can see, when x is minus 2, it's easy for us because this bracket becomes 0. I can automatically, I can immediately get the value of b. So 4 into minus 2 is minus 8 plus 3 equal a into minus 2 plus 2 plus b. So I end up getting minus 5 equal, this is 0 plus b equal minus 5. Okay, so I end up getting b equal minus 5 and then getting the a value. So you could substitute any value you might be thinking, what other value can we put for, can we put any value we want for x? Yes, you can actually put any value you want for x. You want to put x is 1, you can put x is 1, x is 10, like you can put any value you want. So just be strategic about the x value you use. So I use the x value minus 2 because it makes this term become 0, and then I can easily find b. So the next thing that you can do here is, now after putting x equal to, I got minus 2, I got the value of b. Now I just need to find the value of a. So to find the value of a, you can actually use any value, any x value you want. It does not change the figure. So I think I'll just go with maybe x equals 0. Just put any value that is easier. X equals 1. So because we already have the b value, we only have one more unknown. So any x value that you prefer, x is 0, x is 1, x is 10, anything, it really does not matter. So 4 into 0 is 0 plus 3. 4 into 0 plus 3 equals a into 0 plus 2 plus b. So remember to input the b value because we found b. So 4 into 0 is 0 plus 3 equal a that is 2a, right? Plus b is minus 5. So 5, 6, 7, 8 equal 2a, a equals to 8 divided by 2, a equals 4. So give your answer in the format. So they wanted us to express 4x plus 3 over x plus 2. So 4x plus 3 over x plus 2 equals a plus b over x plus 2. So I'm trying to give this answer here. So a equals 4 plus b is minus 5 over x plus 2. So this is the answer for part A. So let's move on to part B. Actually, I told you I would, no, I think this is better. Okay, so we just do it in this way. So you could do long division as well. So any method, it's just fine as long as you get the answer, as long as you get the A and B values correctly, all methods are okay. Okay, then the next one is to do part B, hence find using algebraic integration the exact value of 4x plus 3 over x plus 2. So actually you just need to integrate what you got in part A. So integrating from minus 8 to minus 5, 4x plus 3 over x plus 2. So actually, you know that this guy, what we found, what we have in part B, this is equivalent to, you just found that it's equivalent to 4 plus minus 5. So actually plus minus is minus, isn't it? So this. So I replace this inside 4x plus 3 over x plus 2 with this guy. So now it's time to integrate. So integrating simply 4 with respect to x gives you 4x. Integrating minus 5 times 1 over x plus 2. So 1 over ax plus b integration. So integration of 1 over ax plus b is 1 over a times ln ax plus b. So these are rules that you need to know. So 1 over a times ln of ax plus b. Okay, so this is the integration of 1 over x plus b. So minus 5 times integration of 1 over x plus 2 is the a value here is 1x. So a is 1. So 1 over 1, actually, it's not, that's not, you don't have to write it, into ln x plus 2. Okay, and you don't have to put the plus c because we actually have limits here in between minus 5 to minus 8. Okay, so let's put the values here. 4 into minus 5 is minus 20. Minus 5 times ln minus 5 plus 2 is minus 3. So it's a modulus sign here, remember, inside the ln, because inside the logarithm we keep the modulus sign because our logarithms are supposed to be positive. So I'll fix that. Compulsory minus, put minus 8 now, replace x with minus 8. 4 into minus 8 is minus 32. Minus 5 times ln minus 8 plus 2 is minus 6. So when you fix this, remember, I'll open the bracket, minus 20 minus 5 ln 3. So as you can see, I removed the negative sign because it's a modulus sign. You don't keep your inside of the logarithm positive, okay? Here minus minus is plus 32. Here again you have plus 5 ln 6. Okay, so let's simplify. 20 plus 32, that's going to give me 12. So if I take a plus 5, there's a minus 5 ln3, there's a plus 5 ln6. So if I take a plus 5 out from these two guys, I end up getting ln6 minus ln3. Is that okay? Yeah, I took the 5 out from these two guys. 5 is common. So I took a plus 5 out. So therefore, I have a plus ln6 and a minus ln3. So subtraction of the same base logarithms. So when two logarithms with the same base as when the same base are subtracted, it's a division. So 6 divided by 3. So 15. I'm sorry, it's not 15. It's 12. So 12 plus 5 ln 6 divided by 3 is 2. So 12 plus 5 ln 2. So they have told you asked to give your answer in the simplest form. So and the exact value. So it's important that you give your answer in exact values. So don't go to type the whole thing in the calculator at once immediately, and it will give you a decimal figure. So you need to do this manually to get the answer in the exact form. Okay. Okay, so moving on to question number 4. The functions f and g are defined by fx equals 4x plus 6 over x minus 5 and gx equals to 5 minus 2x squared. So actually the functions, they've given you a domain as well. So in fx, x is not equal to 5. I think we can understand why that is, because if x equals 5, we get the math error. So x is not equal to 5. And in this one, they have given you the domain here, x values for this particular quadratic maximum graph. Isn't it? It's a quadratic maximum graph. For this function, the domain is given for x values smaller than or lesser than or equal to 0. Okay, so those are just have a idea about those things as well when you are reading the sums. Okay, so they might be important at the later stage. Solve the equation f of gx equals 3. Okay, it's a compound function. So let's find f of gx. So f of gx equals 3. So first fx. So fx equals to 4x plus 6 over x minus 5, right? So f of gx. So when they say f of gx, it means the x here needs to be replaced by your gx, which is 5 minus 2x squared, isn't it? So the gx, the x value should be replaced by the gx figure, which is 5 minus 2x squared. So f of 5 minus 2x squared. So that is the f of gx, isn't it? Or if I say here f of gx is, I write f of gx, you replace all the x values 4 times gx plus 6 over gx minus 5, isn't it? You replace all your x values with gx here. So then gx is 5 minus 2x squared, 4 times 5 minus 2x squared plus 6 over 5 minus 2x squared minus 5. So let's simplify this equation, and then they've told us that f of gx is equal to 3. So this is equal to 3. Simplify. 5 times 4, 20. 4 times 24 times 2 minus 8x squared plus 6 over plus 5 minus 5 cancels, and you end up getting negative 2x squared at the denominator. So I'll bring the negative 2x squared to the other side as a multiplication. 3 multiplied by negative 2x squared gives you negative 6x squared. 20 minus 8x squared plus 6. So I'll take everything to one side. Let me take everything. In this sense, I have only x squared here, isn't it? So I have directly x squared here. The other figures are okay. So plus 8x squared minus 6x squared is 2x squared. 20 plus 6 is 26, which means x squared equal to 26 divided by 2, 13. X equals to square root of 13. So remember, when you're putting the square root, it's plus or minus. However, so x equals plus or minus. Okay, and then minus root 13. Yeah, and then we need to choose the correct figure here. So we know x values are not equal to 5 and x values are lesser than 0, isn't it? So then you need to choose the proper figure here. So the correct answer for x should be x equals negative root 13. So we make sure that you specifically mention it. So after you put the square root and you put the plus or minus, you need to choose the correct answer. The correct answer is only negative root 13. So positive root 13 is not an answer because it doesn't fit into the domain. Okay, so it has to obey the domain. Domain false for x value is lesser than 0 and x value not equal to 5. So you must make sure that your domain falls under this, under meets these criteria, meets these conditions. So x equal negative root 13 meets the condition, right? Okay, then part B, find f inverse. X part B, f inverse x, let's find, so fx or rather y equals 4x plus 6 over x minus 5. So normal procedure to find f inverse is that we switch x and y, right? We switch x and y, so x equals 4y plus 6 over y minus 5. So we switch x and y, and now we again, we try to make y the subject, right? So we switch, and the next step is to make y the subject. So I'll bring the y minus 5 to the other side as a multiplication. So you get here x times y minus 5 equals 4y plus 6. So open the bracket, xy minus 5x equals to 4y plus 6. I'll try to bring the x terms to one side, xy. So I'll bring the 4y here, xy minus 4y equal. The 5x comes to the other side, 5x plus 6. Bringing, so to make y the subject, y is common here, I'll bring y out. So y out, x minus 4 equals 5x plus 6, okay? So that gives me y equals 5x plus 6 over x minus 4, which gives me f inverse x. F inverse x equals to 5x plus 6 over x minus 4, okay? So it's quite straightforward. So moving on to the next part. Okay, so moving on to the next part. Solve the equation, find f inverse x. Okay. Sketch and label on the same axis the curve with the equation y equals gx and the curve with the equation y equals g inverse x. Okay. So you got to draw gx and you got to draw g inverse x. Show on your sketch the coordinates of the points where each curve meets or cuts the coordinate axis. Okay. So let's get started. Gx is equal to 5 minus 2x square. So you need to notice a few things about this. The first thing is that it's a x square function, which means it's a quadratic. So it's a negative 2x square, which means you identify this to be a maximum. So it's a maximum. Okay, so it's a maximum. 5 minus 2x square, it's a maximum. So then what we need to do is we need to draw the quadratic function. So basically what we do is we find the place where the graph cuts the x-axis and the y-axis. So when you cut the x-axis, y equals 0. So 0 equals to 5 minus 2x square. So I end up getting 2x square equals 5. Right? So I end up 2x square equals 5, which means x square equals 5 over 2. So x equals square root 5 over 2 plus or minus. So once again, your domain comes into play here. So the correct x value is only x equal negative root 5 over 2. Okay, so I will show that in the graph. Let's just keep this here for the moment, and then we'll find the place where it cuts y-axis as well. So when you cut y-axis, x is 0. So y equals 5 minus 2 into 0 square, y equals 5 minus 0, y equals 5. Okay, y equals 5. So let's draw the graph. So it's a quadratic maximum graph. So basically, the cutting points, normally quadratic maximum, you expect to draw this kind of graph, right? So however, when you're drawing this graph, again, be aware of the domain. So actually, the graph should only be drawn for the negative x values, isn't it? The graph does not go for the positive side. So I'll draw the full graph for the first, I'll draw the full graph like we do in P1. And I'll erase the part of the graph that we don't need. So if I take the graph, negative root 5 over 2 is, let's say it's over here. Positive root 5 over 2, let's say it's over here. So then the y-axis cutting point is 5. So when you draw your quadratic graph, it goes like this, isn't it? So the quadratic graph, it's a quadratic maximum. Okay, so so it's fine. So anyway, we have this graph, but anyway, you all know the rule that the positive x figures. So you can see these are the positive x figures, right? Positive x figures. These positive x figures, for the positive x figures, the graph part should be removed. So they've told us very clearly x is less than 0. So therefore, I can remove that part, right? So I remove this part. So this is the only part of the graph that I need. I don't need the other half of my maximum graph. So this is the original GX graph. And now what do they want us to do? So they want you to draw the G inverse. They want you to also draw the G inverse. Show on your sketch the coordinates of the points where each curve meets or cuts the coordinate axis. So I've drawn this. Now to draw G inverse. So what's the trick of drawing an inverse function without going through a lot of trouble? The easiest way to draw the inverse function is what we call as reflection on the line of y equal x, right? So you reflect to get G inverse, you reflect gx on y equal x. That means you reflect your original graph on, so reflect gx. You don't have to write these things, huh? Reflect gx on y equal x. So you don't have to write these things. These are just stuff that I'm giving you. So what do you mean by reflecting a graph on y equal x? So basically reflecting a graph on the line y equal x. So y equal x line, reflecting on it is pretty special the way it works. So when you're reflecting on y equal x, basically what happens is your x1, y coordinates, they interchange, they switch. So basically what you got to do here is you need to switch x and y. You need to switch your x and y and you can get the new graph. So let me show to you what I mean here. So here the coordinate, for example, this is 0, comma 5, this cutting point. This is minus root 5 over 2, comma 0. So when you switch them out, 0, comma 5, it becomes 5, comma 0. 0, comma 5 becomes 5, comma 0. So that comes, over to the other side, 5, comma 0. So bring it over here and this guy, switch it, minus root 5 over 2, comma 0. So when you switch, x becomes 0, y becomes negative root 5 over 2. So that means it comes somewhere over here, right? So negative, you get 0 first, x is 0, and then you get the negative root 5 over 2. And then just draw the same graph. You have the half of the maximum graph. So you kind of need to draw half of this graph over here. Okay, so just try to draw it nicely. Something like this. Okay, so you need to mark every place where your graph meets or cuts the coordinate axis. Okay, so so this is the G inverse graph. So basically G inverse x graph, you reflect the original GX graph, you switch the x and y coordinates and immediately you get the G inverse x graph. Okay, so I have marked all the places where I cut the coordinate axis as well. Okay. Okay, so moving on to question number 5. The growth of duckweed on a pond is being studied. The surface area of the pond covered by duckweed is square meter at a time t days after the start of the study is modeled by the equation A equal P times Q to the power T, where P and Q are positive constants. Figure 1 shows the linear relationship between logarithm A to the base of 10 and T. The point 0, 0.32 and 8, 0.56 lie on the line as shown. Find the 3 decimal places the value of P and the value of Q. Okay, so how do we find the value of P and the value of Q? Okay, so what we do here is, okay, so it's 4 marks, and what we need to kind of do here is we need to kind of get an idea about the straight line, right? So what kind of a straight line have we drawn? Now we know that this is, A equals P times Q to the power T. This is obviously, it's an exponential type of equation. So they've actually, made it, so they've actually made it into a straight line. The exponential, they made it into a straight line. So we have this theory in P3 in chapter 5, in the exponential chapter, where you have this method where you use logarithms to actually convert these kinds of logarithm graphs into straight line graphs. So you can see here, your variables are P and Q are constants. A and T are the variables, but you can see when they have drawn the graph, they have taken T and logarithm of it. Okay, so then this should give us the clue as to what we need to do here. So this is actually a theory that you've been taught. So what you need to do here is picking up the hint here. You have log base 10a. So what you do here is you replace both the, you input log base 10a to both the sides. Log base 10a equals log base 10 times p into q to the power t. So this is what you should do. Take the logarithm base 10 of both the sides. So then log base 10a, this side you have inside the logarithm, it's a multiplication, p multiplied by q, right? So inside a logarithm, inside a single logarithm, if there's a multiplication, that means you can break it up as an addition of two separate logarithms, isn't it? So p2. So when there's a multiplication, you break it up. So log base 10p plus log base 10 q to the power t. So this is the rule. Okay, so log base 10t plus log base 10 q to the power t. So let's fix it. Log base 10a. So I can simplify that guy a little bit more. The power t, we can bring it forward in a logarithm. You know, the power can be brought forward, right? So plus t times log base 10q. Okay, so actually we got our equation. If you see here, this is your y. Log base 10a is your y. T here, so this is the y value. So t is the x value here, isn't it? So t is the x value, which means y equal mx plus c. So log base 10q stands to be your gradient, while log base 10b stands to be your intercept. So y equal mx plus c. So you can see who is the gradient, who is the intercept here. So they have given you the coordinates. I think you can calculate the gradient and the intercept, and you can get the p and q values. Let's get started. So gradient. So gradient. So let's take the gradient y difference over x difference. 0.56 y difference 0.56 over 0.32. Divide by x difference 8 minus 0. Okay. Okay, over 8 minus 0. So gradient is log base 10q. So log base 10q is your gradient. So give the whole thing in the cal. So I have here 0.56 minus 0.32 over 8 minus 0. This gives me 3 over 100 or 0.03. 0.03. So now the final stage step of finding q. So to find q, what do we do? They want us to find find to 3 dp, right? So 3 dp, the value of p and q. Okay. So the next thing you do is you convert log to index. So log to index, what you get here? 10 to the power 0.03 equals to q. So P2 theory, turn in log to index. 10 to the power of 0.03 equals to q. Okay, so then you can get the answer of q to 3 dp. So q equals 10 to the power 0.03. This gives me 1.01715. 3 dp, when I correct 5 rounds off to give here 2. So 1.072. So the answer of q equals 1.072. So this is the answer of q. Okay, so now similarly you have to get the value of p also. So when I look at p, I can see p is involved with the logarithm of log base 10. So p is involved in this manner. However, we can see here log base 10p is our intercept. So intercept is the place where your graph cuts the y-axis. So intercept is the place where the graph cuts the y-axis. So your y-axis is cut at the y value 0.32. So which means your intercept is 0.32. So intercept is also log base 10p equals to 0.32. I hope this is clear with you all. So so then what we do here is we take log to index. So 10 to the power of 0.32 equals to p. So turn in log to index. So now it's a matter of giving the whole thing in the cal. 10 to the power 0.32. So that gives me 2.0892. So 3 dp, the 2 is smaller than 5, so 2.089. So p equals to 2.089. Okay, so those are the values of p and q to 3 decimal places, correct to 3 dp. Okay, next one, using the model with the values of p and q found in part A, find the rate of increase of the surface of the pond. So it's important you notice the word rate here. So normally rate means how fast. Okay, so the rate implies that you have some kind of a differential function here. Okay, So find the rate of increase of the surface area of the pond. So rate of increase of the surface area of the pond. So that means that's to do with area dA covered in duckweed in meter square per day. So the unit is given here. So meter square is area per day. Per day is the time here, right? 3 days. Time is T. So this is the rate of increase. In other words, this is actually what dA by dt. They're asking you to find dA by dt. Exactly 6 days after the start of the study, give your answer to 2 dp. Right. So let's get it done. Part B. So we know A equals P times Q to the power ln T. So P and Q are actually constants, right? P and Q are actually constants. P times Q to the power T. Remember, P and Q are constants, which we have already found. So let's put it within. So P is 2.089 multiplied by Q is 1.072 to the power T. So now let's get dA by dt, and you have to find the value of the dA by dt for exactly 6 days, at time 6. So how do you differentiate, dA by dt? So here, this is not a product rule because 2.089 is simply a constant. Here you have exponential function, right? So a to the power x differentiation, a to the power x differentiation is a to the power x times ln a, isn't it? A to the power x times ln a. This is if you differentiate with respect to x. Of course, here differentiation happens with respect to t. 2.089 is a constant, let it be there. 1.072 to the power t, it differentiates to give you 1.072 to the power t following this procedure into ln of 1.072. Okay, and then so this is our dA by dt. So now replace t with 6. So input t as 6 and get dA by dt. So just a matter of typing the whole thing in the calc. 2.089 multiplied by 1.072 to the power of 6 into ln 1.072. Is that correct? 2.089 1.072 to the power 6 into ln 1.072. So that gives me 0.2204. They want the answer to 2 decimal places. So 0.22. 0.22 square meter per day. So this is the rate of increase of the surface of the area of the pond. Okay. Okay, so moving on to question number 6. Given that k is a positive constant on separate diagrams, sketch the graph with equation y equals k minus 2 times modulus x and y equals full modulus of 2x minus k over 3. Okay, so here we can see the two types of modulus graphs. So the first one here, you can see the modulus mark is only around x. So in the second graph, you can see the modulus graph around the entire function. So these two types of modulus, the way we draw the rules are totally different, isn't it? So in here, when the modulus mark is only around x, the rule we use to draw this is we sketch the graph. You remove the modulus mark and take the normal graph. You sketch the graph for x values greater than or equals 0. You sketch the graph for x values greater than or equals 0, and then reflect that graph that you drew. Reflect the graph that you drew on the y-axis. So you sketch your graph for the positive x figures, and then the graph which you drew for the positive x figures, you should reflect on the y-axis and draw the negative x figures. So let me show you what I mean. So this is a theory actually. So I'm just giving you a small. I'm not giving you the full idea here, but giving you rather a summary of what's happening over here. Okay, so this is what needs to happen. So I'm not going to go into more details because we are trying to do the paper. So okay, so y equal k minus 2x. What I simply do here is first I'll just eliminate the. I'll just remove the modulus and take the normal graph k minus 2x. And what we do is it's a straight line. And we simply, do the normal thing where we try to find the place where the graph cuts the x-axis and the y-axis. So when you cut x-axis, your y value is 0. So when you make y 0, 0 equals k minus 2x, which gives you 2x equals k, which gives you x equals k over 2. Right? X equals k over 2. And then when you cut the y-axis, x is 0, so that gives you y equals to k minus 2x. So k minus 2x where x is 0. So y equals k. So now it's time to draw the graph. So it's a straight line. The cutting points are given. The cutting points are coming in terms of k. So draw your graph will come in terms of k. Okay. Okay. So I'll draw the graph here. So it's a sketch that they need. So x and y. X-axis cutting point was k over 2 and y-axis cutting point is k. Okay, so if I draw the straight line, I end up getting something like this, right? So this is a straight line. Y equal y equal k minus 2x. So y equal k minus 2x. This is a straight line. So I did immediately I did not think about the modulus. I just drew the graph. Okay, so I just drew the straight line graph. And now what? I mean, after you get all your cutting points and draw the graph, now start thinking about the modulus. So when the modulus mark is only around the x function, what's the rule? You sketch your graph only for the positive x figures. So only for the positive x figures, which means this section, right? Positive x figures means this the positive x-axis. So your graph must only be sketched for the positive x-axis, so not for the negative x. I think you can see that I need to remove this section, right? So positive x-axis, the graph goes over this side, this part. So this particular part is coming for the negative x figures. Can you see over here? It's the negative x figures. So that part of the graph needs to be removed. So I'll be removing that part. So I'm removing, as you can see, I removed. So this part I removed. Okay, so you draw your graph only for the positive x figures, and then the graph you drew must be reflected on the y-axis. So the graph that you drew, so this is the graph that I drew. This graph should be reflected on the y-axis. So this is the mirror line. So just reflect this graph onto the other side. So I think you can see how it comes. Right, this graph is reflected to the other side. So obviously the cutting point will become the plus k over 2. This will become minus k over 2. So let's draw the line. I'll draw it with the same color. So you start from here and you draw this. So this is it. So this is the graph of y equal k minus 2 times the modulus of x. So that's it. Y equal k times 2 modulus x graph. So this is the answer. Okay. So the next graph I have to draw, they say to draw on separate diagrams, sketch the graphs. Roman number 2, y equal modulus 2x minus k over 3. Okay, so here, here you can very clearly see the modulus mark is around the full function. So when you have it like that, what works here is, what we do here is first you draw the normal graph, ignore the modulus sign, ignore everything, just draw 2x minus k over 3 graph, and then after you draw the full graph, what we do is reflect the part below x-axis. Reflect the part below x-axis on the x-axis. So any part of your graph which is below x-axis, you should reflect it above the x-axis, meaning your entire graph is above the x-axis. So, in this situation, if the parts of the graph which are originally above the x-axis, they don't face any change. So the section of the graph which is anyway above x-axis will be as it is. There won't be any issue with that. But the sections of your graph which go below the x-axis, they need to be reflected. They need to be reflected. So meaning below your x-axis, you have a full blank. Nothing below x-axis, everything above the x-axis. Okay, so let me show you what I mean here. So here in Roman number 2 graph, you don't have any restriction about the x values about where you should draw. You should draw the full graph. Regardless of whether it's positive x or negative x, just draw the full graph. Draw the full graph and we will erase the part that is below the x-axis and simply put it up, reflect it up, that's all. So let me draw y equal to 2x minus k over 3. So let's come here. So when you cut, so I will remove the modulus. 2x minus k over 3. So when you cut x-axis, y is 0. So y0 equal 2x minus k over 3 minus k over 3 goes as plus k over 3 equal to x. X equals k over 6. So the x cutting point is x equal k over 6. And the next one, when you cut y-axis, x is 0. So y equal 2x minus k over 3. So when x is 0, y equal negative k over 3. Right? So let's draw that graph also over here. Okay, so let's draw that graph. So we have here the x-axis, we have here the y-axis. So it's cutting point. So I think if you could keep kind of like the same scale, it's better. Then we can compare, because I think at the next part, we might need to do a comparison. So better to keep the same kind of scale here. Okay, so then the x-axis cutting point is at x equal k over 6. So k over 6 is even lower than k over 2, right? K over 6 is even smaller, isn't it? So k over 6, let me mark it over here. This is k over 6. So this is the first cutting point, k over 6, and the other, the place where you cut the y-axis is negative k over 3. Okay, so negative k over 3 is a little bit higher than k over 6, so double of this guy. So negative k over 3. So this is the place where you cut the y-axis, this is the place where you cut the x-axis. Okay, so kind of try to keep a scale. Okay, so k over, so something. Okay, so I'm trying to, because at the end I had to compare these two graphs. Okay, so then when I draw my straight line, I end up getting a graph like this, right? So this is what I end up getting. I end up getting this graph. Okay, so basically, this is the 2x minus k over 3, the straight line, the simple straight line. But now what's the rule I told you when you're drawing the full modulus graph? So when you're drawing the full modulus graph, you reflect the part below your x-axis to above the x-axis. So what's the part below your x-axis? So this is the x-axis. I think you can see this entire section. This entire section is below the x-axis. Can you all see? This entire part of the graph is below the x-axis. So that full part should be reflected up, should be going up. So when you reflect it up, the negative, the y value negative k over 3 should go up as positive k over 3. Okay, I hope you guys can understand that. So what happens here is basically, so I'll have to, I'll erase the full thing afterwards after I draw. So what I do here is I have to bring this negative k over 3 value, which comes up to positive k over 3, and then you draw the graph reflecting up. And then this other part of the graph should be erased. Okay, so this is gonna be erased. So this is the modulus graph. Okay, so this is the modulus 2x minus k over 3 graph. Okay, and one more thing that I really want you all to do here is the moment you draw the graph, we need to individually give the names of the lines as well. So now the graph that we originally drew here was the line with the equation. So this is the original line we drew. So y equal 2x minus k over 3. And I think you guys can see just now a moment ago I reflected this line, the part below was reflected up. So when you're reflecting it up, since this is a full modulus graph, okay, so this is a full modulus graph. In the full modulus graph, so the first graph I drew, that's the I just named the straight line that I drew. The reflected graph will have the opposite sign of this entire section. So opposite sign of the entire section will be negative 2x plus k over 3. So that means the reflected graph has the equation y equals negative 2x plus k over 3. So that's important that you know that each the individual equation of each line here, because the modulus graph is made up of two straight lines. So each knowing the individual equation of each straight line is important. The graph you reflect, always the part that you reflect will have the opposite sign. So this one, the original graph, I named it, and the reflected part gets negative 2x plus k over 3. The same story goes for this graph as well. Y equal k minus 2x. I think the original k minus 2x graph, when we drew the original graph, it came like this, right? So this part of the line, this is the original k minus 2x graph. So name it, this is y equal, so this is y equal k minus 2x. So make sure you name it. This was the original k minus 2x, and then the reflected part. So as you can, I hope you remember just a few moments ago, the part which went, I erased the part that went up, and the positive x-axis was totally reflected on the negative x-axis, right? Positive x-axis is the original graph, and the reflecting part was on the negative x-axis. So this. So in here, you give the opposite sign of your modulus. So where is the modulus now? Don't go to change the sign of the whole thing, because the modulus mark is there only around the x. So here we took the positive sign of the modulus, k minus 2 times just the x. The opposite sign of the modulus you should take minus 6. So k minus 2 times minus 6. So which means the opposite sign of the modulus is k plus 2x. So which means the reflected graph has equation y equal k plus 2x. So actually knowing these equations, it's kind of important. It will be helpful, especially for part B. Okay, so this is the end of the first part, right? So Roman number 1 and 2, sketch on each coordinate axis in terms of k of each point where the graph meets or cut the axis. So we've done that. Okay. So now look at part B. So this is the part that you need to, where you should know about all these equations. Hence find means obviously you have to use the help of part A. Hence find in terms of k the values of x for which modulus 2x minus k over 3. So this graph is equal to k minus 2 times modulus x. So the first graph. So basically they have equated the two graphs. So you should know when they equate two graphs, what does it mean? Equating two graphs means we need to find the place. So that means find the solutions. Where are the solutions? Solutions are at the points of intersections of the two graphs. Okay, so solutions are at the points of intersection. So your solutions are at the points of intersection. Okay, so let's see how we can do it. So all you need to do is kind of look at these two graphs and see which straight lines are meeting. So if I kind of like quickly draw, with the pencil, you could draw one graph on top of the other. I think drawing this graph on top of this is easier. So if I draw this quickly, so the first graph k, negative k over 2 and positive k over 2 is like this, right? So the first graph, I think if I draw it, so just draw it lightly with the pencil, or you can erase, or you can do it with your mind. So I just drew this graph on top of this because I want to see the place where the two graphs are meeting. So actually you can see when you drew a quick sketch like that. Okay, so you can see when you do a quick, make sure you erase this because it should not be there in your part A answer. You can do it in a rough piece of paper, or you can think of it in your head. So anyway, when you draw this graph on top of this, you can very clearly see the cutting points. There are clearly two cutting points. So get the two cutting points. To get each cutting points, what you need to do is you need to solve the respective pair of lines. You have to solve the respective pair of lines. So the first solution is obtained by solving y equal minus 2x plus k over 3 along with what? So what is the other line? The other line is y equal k plus 2x. Can you see? That's why it's important to know your line. You must know each individual line so that when you go to solve to find the cutting points, that you know who each individual line is to find the intersecting point. So here this intersecting point is formed by the intersection of the lines y equal minus 2x plus k over 3 and y equal k plus 2x. This is the k plus 2x line, right, over here. So you solve that, you get the first cutting point, and then to get the other solution, you need to solve y equal 2x minus k over 3. Y equal to x minus k over 3 is this line along with this line. Who is that? So that is this line, right? So this guy. So y equal k minus 2x. So solve these two and you should be good, and you should get the two answers, the solutions in terms of k, giving your answers in the simplest form, and your answers will be in terms of k. So that's it. So solve these two guys simultaneously. So 2x, negative 2x plus k over 3 equal k plus 2x. That gives me k over 3 minus k equal 4x. So I get here k minus 3k, that is minus 2k over 3 equal 4x, which gives me x equals, minus 2k over 3 times 4 is 12. When I simplify, I get x equal negative k over 6. X equal negative k over 6. So that is obviously going to be this cutting point, minus k over 6, right? And then the other solution, simplify 2x minus k over 3 equals k minus 2x. Bringing the negative 2x here as plus 2x. K plus k over 3. I brought this guy here as a plus 2x is 4x. 3k plus 1k, that's 4k over 3. So x equals 4k over 3 times 4 is 12. So x equals k over 3. So x equals k over 3. So these are your two solutions. So here x equal k over negative k over 6 and x equal k over 3. These are your two solutions. So give the answer for part B, x equal negative k over 6 and x equals k over 3. So these are the two solutions. And at the end of the day, so remember that your part A answer should not, each graph should be properly mentioned. Now you can't, you can't contaminate your graph in this manner. So you should erase if you drift this part, because I drift this graph on top of this. So it should not be there. You could erase it out. As I said, you could use a rough paper, just to see how the graphs are intersecting. So I kind of, so we need to make sure that if we keep this, we will lose marks for part A. So make sure that it's erased. Okay, so that's it. So this is the answer for part A. This is the answer for part B, where the two graphs are intersecting. Okay. Okay, so moving on to question number 7. Given that x equals 6 sine square 2y, show that dy by dx equals, 1 over a times root bx minus x square. 5 marks. Let's get started. So x equals 6 sine square 2y. So let's differentiate. So you could differentiate with respect to x, or you could differentiate with respect to y. So entirely up to you all which way you differentiate. So I'll differentiate with respect to y. Okay, so I'll differentiate with respect to y, which gives me dx by dy. Okay, so if you differentiate with respect to x, differentiation of x will give you 1. But if you differentiate with respect to y, then x becomes dx by dy. Okay, so here you get 6 times sine square 2y. So what's the rule here? So the rule here is simply, if you have some power when you're differentiating, first priority goes for the power n times fx to the power n minus 1 times f dash x. So this rule here states that if you have a function with some kind of a power, you deal with the power first, and after you're done with the power, you go inside and differentiate the fx function. So it's the same rule here. Here sine square 2y, which means sine 2y to the power of 2. So first deal with the power 2. First you need to deal with the power 2. So I'll bring the power 2 forward like in this rule. So 2 times sine 2y to the power 2 minus 1. So I just did this part. Okay, bring the power in front, subtract 1 from the power. After you're done with the power, go inside and differentiate the inside function. So what's the inside function? I'm done with the power. Then go inside sine 2y. Sine 2y differentiation is cos 2y. And then after you are done with sine, becomes cos. After you're done with cos, go inside the angle. 2y differentiation is 2. And the y differentiation is simply 1, because we are differentiating with respect to y. So since you are differentiating with respect to y, it's simply 2, just 2 into 1. So just 2. Okay. So we are, so now it's a matter of, simplifying this. Dx by dy equals, so 6 times 2, 12, 12 times 2, 24, or you could say 6 times 2, 12 times 2 sine 2y cos 2y. Like I prefer to keep like this. Okay, 6 times 2, 12, and there's another 2 sine 2y cos 2y. Okay, so okay, I need to get this show that, right? I need to get the show that saying that. Okay. So what do we know about, I mean, I need to get my answer in terms of x. Actually, you can see the answer is fully in terms of x. So there's no y function. So I need to kind of, simplify here and replace the sine 2y and cos 2y in terms of x. So actually, let's put 24 here. No use of keeping this guy out. So, okay, 24 sine 2y cos 2y. Okay, so what can I mean, how can I replace here? So don't go to use double angle rules here. Sine 2y is 2 sine y cos y. You will only go further away from your answer because we need to get our answer to into x. You need to make it look like, I mean, you need to make it into an x function. So x is 6 sine square 2y, which is the double angle function, the 2y. So if you go to replace sine 2y with 2 sine y cos y and cos 2y with the double angle rules, 1 minus 2 sine square or something like that, it's going to it's not gonna come any closer to your answer because you're going further away from your answer. Okay, so all you got to do here is, I think best thing you could do here is kind of like find, make sine 2y the subject, get the answer in terms of x. So I can see here x equals 6 sine square 2y. So which means x over 6 equals to sine square 2y, which means sine 2y equals to root x over 6. Okay, so sine 2y equals to root x over 6. So that's what I need here. Here sine 2y is directly root x over 6. Similarly, also get cos 2y. So how do I get cos 2y? Obviously, the easiest way to get it is by using the identity sine square theta plus cos square theta equal 1. So in this case, the theta will be 2y. Sine square 2y plus cos square 2y equals 1. So sine square 2y, I think I have the value over here. Sine square 2y equal x over 6. Cos square 2y equal 1. So cos square 2y equal 1 minus x over 6. So simplifying, let's just make it a little bit easier for us. Cos square 2y equal 6 minus x over 6, which gives me cos 2y equals modulus 6 minus x over 6. Okay, modulus 6 minus x over 6. So then let's put the values over here. Dx by dy equals 24 times sine 2y is root x over 6 into cos 2y is root 6 minus x over 6. Okay, so now simplify and we have to make it dy by dx, right? So let's work on this. I just need to turn the whole thing upside down. I'll do it at the very last second. So 24 times. The third numbers, you can multiply it immediately. So root immediately inside one third. X times 6 minus x. X times 6 minus x over 6 into 6 is 36. So actually you can now turn it dy by dx. So I'm going to turn this to the other side, meaning I turn the whole thing upside down, equals 1 over 24. The third also turns upside down, 36 over x times 6 minus x. So I think you can see 36 is a perfect square which we can take out of our root. So 36 comes out as 6. Square root of 36 is 6 over 24. So times you have here 1 over square root of 1, right? So actually it's just you get here 1 over. So you get here 6x minus x square. So you can simplify this out. So dy by dx equals 6 over 24 is 1 over 4. So basically you have here 1 over 4 times square root of 1 is 1. And you have here root of 6x minus x square. So I think we are close to our answer, right? Yeah. So just simplify, give the final answer in the format they want. 1 into 1 is 1 over 4 times square root 6x minus x square. So I think this is the format, right? This is the format. 1 over a bx minus x square. So 1 over 4 ax minus x square. So that's it, right? So we have got it to the format. Okay. Okay, so moving on to question number 8. A scientist is studying a population of fish in a lake. The number of fish, capital N, in the population 2 years after the start of the study is modeled by the equation n equals 600 e to the power 0.3t divided by 2 plus e to the power 0.3t. Use the equation of the model to answer parts A, B, C, D, and E. Find the number of fish in the lake at the start of the study. So at the start of the study, at the start means the start, obviously they are referring the time here. At the start, time is, so obviously at the start, time is 0. So how many, what's the number of fish you have in the lake? So n equals 600, n equals 600 e to the power 0.3 times 0 because time is 0 divided by 2 plus e to the power 0.3 times 0. So you end up getting 600 e to the power 0 divided by 2 plus e to the power 0. Any number to the power of 0 is 1. So that gives you 600 times 1 over 2 plus 1. 600 divided by 2 plus 1 is 3, which gives you 200. So n equals 200. That's the number of fish in the lake at the start of the study. So simply 1 mark. You could do that in a very few number of steps. So let me erase all these steps. You don't need to write all of that. Just writing one step is more than enough. You could write 600 over 2 plus 1. That gives you 200. 600 divided by 3. Okay, so just a few steps is enough. We have simply 1 mark. Part B. Find the upper limit of the number of fish in the lake. So the upper limit. So how do we find the upper limit to the number of fish in the lake? So for this, you do require to think a little bit. You do need to think a little bit. So the rule here we use for exponentials is the e to the power negative x graph. So I think you need to have an idea about this particular graph. In the e to the power negative x graph or e to the power negative t, say let's say minus t. So minus x minus t, and so whatever the graph it is, when your time goes to infinite, so when your time is extremely large, when the t value is extremely large, e to the power negative t will it tends to 0. It comes closer to 0. So this is the rule that you need to use here. Okay, so the when your t values get larger and larger, your e to the power minus t graph becomes smaller and smaller, becoming closer to 0, because you know that at e to the power minus t, this line is y equals 0 is asymptote, isn't it? So it's actually true for e to the power minus t, e to the power minus x, in other words, or e to the power whatever the value here. So say you have e to the power minus 5t, or e to the power minus 10t, or e to the power minus 0.3t as in our case. So it really doesn't matter. The shape of the graph does not change regardless of what you have over here. So e to the power negative 80. So if I put like that, it really doesn't matter here. Okay, the rule does not change. So regardless of the figure you have here, because the figure here is affecting the y coordinate, the x coordinate. Sorry, it affects the x coordinates. So when you affect the x coordinates, the cutting point 0, 1, the x coordinates are not affected. The x coordinate and the x coordinate is 0 here, so it's not changed. And here you have a y asymptote, so the y asymptote is also not affected. So just to explain in a nutshell, what you need to understand here is when you have these kinds of exponential functions and they ask you to find an upper limit. Okay, and if they ask you to find an upper limit, basically what you need to do is you need to make sure your graph is in the e to the power negative exponential. You have to make your e to the power negative exponential type, and you have to send your time. You have to make your time, send your time to infinity, and then make your e to the power negative t function become 0, and then you can get the upper limit. So what I do here is to convert this graph. Now I have n equal 600 e to the power 0.3 t over 2 plus e to the power 0.3 t. This is what I have, right? So you can see here I don't have any negative exponentials. My e to the powers are all positive. So what I do here is I multiply, okay, because I want to send time to infinity, but I can't do it with e to the power positive t. E to the power positive t, when time goes to infinity, the graph is really large. So this I can't work with that. So what I'll do here is, you know, equivalent fractions, you can multiply both sides of the fraction up and down by the same figure. So I'll multiply both up and down by e to the power minus 0.3 t. So when I multiply both up and down by e to the power 0.3 t, I get here 600 e to the power 0.3 t into e to the power minus 0.3 t. That gives you, adds the power, it becomes e to the power 0. Here when you multiply 2 times, you get 2 times e to the power negative 0.3 t plus e to the power 0.3 t into e to the power minus 0.3 t. That gives me e to the power 0, which is, so all of them are becoming 1. So 600 over 2 e to the power negative 0.3 t plus 1. And now what you got to do is you got to send your time to infinity, because you know when time goes to infinity, e to the power negative, these functions are becoming 0. Okay, so that's the rule. Just apply this rule. That's all you need to know here. Okay, regardless of anything about the graphs, just forget when time is extremely large, e to the power negative functions, regardless of whether it's 2t, 10t, 0.3t, whatever the power here, it will become 0. It will become 0. So this becomes n equals 600 over 2 times e to the power negative becomes 0. When time tends to infinity, e to the power negative 0.3t will tend to 0. Okay, so that's the rule here. This guy becomes 0 plus 1 plus 1. So that gives me n equals 600 over 2 into 0 is 0 plus 1. So the upper limit of your population is simply 600. Okay, so this I was explaining this to you a lot. So I mean, it should not take such a long time during the exam. You could do in like a few steps, like I could do in like 2 steps. But I did elaborate and I did write a few extra steps to make sure that you kind of can understand. Hopefully, you may be able to understand what I'm talking about. However, if there are any issues, you can mention it in the comments, and I could help you out with that. Then moving on to part C. Find the time of the start of the study when there are predicted to be 500 fish in the lake. Give your answer in years and months to the nearest month. So your answer in years and months. So please pay attention to these tiny details, because if you miss these small things at the end, you will not get the full mark. Okay, so find the time. You have to find the time of the start of the study when there are predicted to be 500 fish. So when will there be 500 fish? You have to find the t. So let's get it done. Part C. So n equals 600 e to the power 0.3t over 2 plus e to the power 0.3t. So I will replace the n is 500. So I need to find the time when n becomes 500. So then to make things easier, some of you might find it very easy to do it with the e to the power 0.3t. But I know many of you may have trouble with that. So if you can directly do the entire sum, what I'm going to do next with e to the power 0.3t, please go ahead. There's no problem. Otherwise, if you find it difficult, you could, replace let e to the power 0.3t be x. You can do something like that. Okay, or else you can directly go in the way that I'm doing. So 500 times 2 plus e to the power 0.3t equals 600 times e to the power 0.3t. So this gives me 500 times 2 is 1000 plus 500 e to the power 0.3t equals 600 e to the power 0.3t. So when I subtract, I get here 1000 equals 600 e to the power 0.3t minus 500 e to the power 0.3t. Can you see? I brought this to the other side as a subtraction. So 1000 equals 600. So this is like a 600a minus 500a, because these are two like terms. So you can subtract them. 600 minus 500 is 100 e to the power 0.3t, which gives me 1000 divided by 100. So I get 10 equals e to the power 0.3t. So the final step of making t the subject. So I think we need to turn log to index, isn't it? Sorry, index to log. So turn index to log, or you could put ln to both the sides of your function. So both okay. Either you could put ln to both sides of your function, or you could directly turn log to index. So if I turn log in index to log, you get here e to the power 10. Sorry. No, we are not going to use index to, yeah, we can use log base e10 equal 0.3t. This is what you would get, right? A to the power b equals c. You get log base a c equal b. This is p2, right? Log base a c equal b. So I just did the same thing here, the same rearrangement. E becomes the base, 10 comes over here, the power becomes your answer. So log base is ln e. ln. Log base is ln, and this is 10. ln 10 equal 0.3t. So ln 10 divided by 0.3 equals to your time. Okay. And then what you got to do is you need to take your cal and type the whole thing and give your answer in years. So the time is in years, right? So we'll check that. So this is ln 10 divided by 0.3. So that gives me 7.67528 years or months. I think it was in years, right? The time is measured in the number of fish in t years. So you get the time in years. Okay, you get your time in years, and they want us to find the time now for this time in years and months. So the time in years and months for the population reach 500. So you can see we get 7.67528. So let me write that 7.67528 7.67528 years. Okay, let me check that again. 7.67528. So I just took a few decimals, and now you need to convert this to years and months. So time equals, you have 7 points. So 7 points means you have 7 complete years. So 7 complete years plus another 0.67528 years. So that is the remaining, the amount that the remaining part, right? 7 complete years plus another 0.67528 parts of a year. So then what you do is you, so I take that part, 0.67528 parts of a year, and then we multiply it with 12 because a year has 12 months. So this is a 0.67528 parts of a year multiplied by 12, and it gives us 8.1 months. I think they want it in the nearest month. So 8.1 months means 8 months. Can you see? So we have 8 months. So this years, I'll multiply this with 12, and this becomes months. So this gives me the time equals to 7 years and 8 months. So you need approximately 7 years and 8 months for the population to reach 500. Okay. So this is how it's done. Then moving on to the last part, part D, right? We need to do part D. Show that dn by dt. Okay, so that means you're supposed to differentiate here. Okay, so let's differentiate. Okay, question number part D. Show that dn by dt. So n equals 600 e to the power 0.3 t over 2 plus e to the power 0.3t. So differentiating this, of course, I will have to go with the quotient rule, right? So in quotient rule, how do you deal with the quotient rule? The denominator is squared, right? So the denominator 2 plus e to the power 0.3, denominator is squared into denominator times differentiation of the numerator, right? Into denominator times differentiation of numerator. Numerator is 600 e to the power 0.3t. So e to the power 0.3, when you differentiate, it's again 0.3, isn't it? 600 is a constant, e to the power 0.3 differentiation is e to the power 0.3, the same thing, into 0.3 differentiation is 0.3, right? The differentiation of e to the power the differentiation of e to the power of x is, you differentiate the e, you get the same thing into differentiation of the power. So the power 0.3 differentiation is 0.3. Then continue with the quotient rule, negative, so minus, and now the numerator times, differentiation of the denominator. So what's the denominator differentiation? So you have differentiate the 2 plus e to the power 0.3. 2 differentiation is 0. E to the power 0.3 differentiation is e to the power 0.3t into 0.3t differentiation 0.3. Okay, so just to give you a heads up, EFX differentiation is EFX into the f dash x. That means the differentiation of the e function is the same thing. You write the same function again and into the differentiation of its power. So e to the power 0.3t differentiation is e to the power 0.3t into 0.3 differentiation is 0.3. Okay, so now it's a matter of simplifying this and trying to get the show that. So dn by dt equals, so let's try to simplify. 600 into 0.3. So I think 600 into 0.3, that is 6 times 3, 180, right? So let me simplify. So 180 e to the power 0.3t times 2 plus e to the power 0.3t. 600 into 0.3, there's another one here. So 600 into 0.3, that's another 180 e to the power 0.3t. 0.3t gives you 0.60. Same base multiplication, powers are added. Divide by 2 plus e to the power 0.3t whole thing square. So let's open up the bracket in our numerator. E to the power 0.3t into 2, that gives me 360 e to the power 0.3t, okay, plus 180 e to the power 0.3t into e to the power 0.3t. I think you can see that's going to give you 180. So e to the power 0.3t, when you multiply with e to the power 0.3t, the powers will add. So that gives you e to the power 0.60. Okay, and then separately there's another minus 180 e to the power 0.60 over 2 plus e to the power 0.3t whole thing square. So now it's time to, I think you can see very clearly in the numerator, these two guys will cancel off. And then I think we get our show that, isn't it? So dn by dt equals 360 e to the power 0.3t over 2 plus e to the power 0.3t whole thing square. Okay, so that is the show that. So the a value, the a is a constant to be found. So a will be 360. The value of a is going to be 360. Okay, then the last part, part E. Given that when t equals capital T, dn by dt equals to 8. Find the value of capital T to 1 decimal place. So dn by dt equals 8 when simple T equals capital T. So can you see, replace the T with capital T. So over 2 plus e to the power 0.3 capital T whole thing square. Okay, so I think in this situation, so I did not go to in the other situation. I was telling you even in the earlier sum, if you found it, if you find it difficult to the simplification with e to the power 0.3, you can replace it with another letter. So I think I will definitely do that over here. So I think it will be easier for everyone to understand. If you are comfortable with going with e to the power 0.3, please go ahead. Okay, however, I will use a small substitution to make it easier for the others. So let me say x equals, so x is not a figure we've used anywhere, right? Throughout this entire sum, there was no x, okay? So let x be equal to e to the power 0.3t. Okay, so I'm going to say x is equal to e to the power 0.3t. So remember, at the end, you must, you are getting your answer now in terms of x when you do this replacement. So at the end, you must remember to bring it back. So 360 e to the power 0.3t is now going to be x. And this is 2 plus x whole thing square. So this looks a lot easier now, isn't it? Like it looks a lot better. So 8 times 2 plus x square equals 360x. So I think the 8 and 360 we can simplify it, right? So 360 divided by 8. The 8 goes, let me bring the 8 to the other side. And 2 plus x square. So you expand 2 plus x square, 2 plus x into 2 plus x. So that gives you 4 plus 2x plus 2x is 4x plus x square. 360 divided by it, that gives you 45, right? 45x. So then when I simplify x square, 45 minus plus 4 minus 45 is minus 41x, right? Minus 41x plus 4 equals 0. This is okay. So we end up getting a quadratic equation. So let's solve it. X equal minus b plus or minus square root b square minus 4 into a into c divide by 2 times a is 1. So I'm kind of showing the method. So I substituted it into the formula, quadratic formula, and then we can just write the answer, because I just wrote a method to show how I got my answer. So equation number 3, and we have here a is 1, b is minus 41, c is 4. A is 1, b is minus 41, c is 4. So we end up getting some really big answers here. Okay, so we end up getting figures like this, right? Okay, so I get a is 1, b is minus 41, c is 4, right? So I've not done any error, hopefully. Minus 45, yeah. Okay, so then when we simplify, the first figure I get is x equal 40.9022. 40.9022. Or x equals, the other figure was, what was it? 0.09779. So now replace back the x. X is e to the power 0.3t. Remember that. So x is e to the power 0.3t. So remember, replace it back, and then you can turn log to index. So log base e 40.9022 equal 0.3t. Or you have log base e 0.09779 equal e to the power 0.3t. Okay, so then it's a matter of typing the whole thing in the cal and dividing. So log base e is ln. So ln 40.9022 9022 divided by 0.3. So that gives you the time 12.37. 12.37, or in other words, time is 12.4 years. So 12.4, and the other answer, I think the other answer, it's not going to be a positive answer because it's a negative of a logarithm. So to show you, ln, log base is ln 0.09779 divided by 0.3 divided by 0.3 equals minus 7.74. This is 0.3t. So time equals minus 7.74. So I think time, you can't get a negative figure for time, minus 7.75. So then this is, so we don't take this figure. So this is not the answer. So the correct answer for this question is 12.4 years. The correct answer is 12.4 years. Okay. Okay, so moving on to question number 9. Express 12 sin x minus 5 cos x in the form r sin x minus alpha. R is a constant positive and alpha is in radians between 0 and pi over 2. So we need to find the exact value of r and the value of alpha. So r is obviously 12 square plus 5 square, right? So you know the rule. You take this two guys, 12 square plus 5 square square root. And that gives us r is 13, definitely. And then you can use you can expand, or you could use tan alpha equal b over a, isn't it? Tan alpha. So this is a sin x minus b cos x. So you could use directly tan alpha. So this is appearing in the book. Tan alpha is b over a, and that equals 5 over 12, and tan inverse. And you could get your alpha. So that is one. That is the easiest way to get it. So it's directly a theory in your book. So tan inverse 5 over 12, however, cal must be in radian mode. So change to radian mode. Tan inverse 5 over 12. So that gives me 0.39479. So to 3dp, 0.395, right? So to 3dp, 0.395. Okay, so give the exact value of r and alpha. So that means 12 sin x minus 5 cos x equals r, that is 13. 13 sin x minus alpha is 0.395. Okay, so r is 13, sin x minus alpha is 0.395. Okay, so moving on to the next part, part B. This was part A. Part B, g theta equals. Okay, so g theta equals 10 plus 12 sine 2 theta minus pi over 6 minus 5 cos 2 theta minus pi over 6. Find the minimum value of g theta. Okay, so obviously what we do here is we need to use the help of our part A. So that we need to use definitely the help of part A. So I can say that 12 sine x and 5 minus 5 cos x is there, just that x is replaced by 2 theta minus pi over 6. So let me put it back. I'm going to replace the x back with this 2 theta minus pi over 6. I'll replace that with x. So then we can easily see the part A value here. Then g theta equals 10 plus 12 sine x. Can you see? I replace the 2 theta minus pi over 6 minus 5 cos 6. So it's replaced. So g theta equals 10 plus 12 sine x minus 5 cos x is 13 sine x minus 0.395. So you replace. So you replace the function 12 sine x minus 5 cos x should be replaced by 13 sine x minus 0.395. Okay, so this is the g theta. Now the task is to find the minimum value of g theta. So how do we find the minimum value of g theta? Okay, so you could, if to see the minimum value of g theta, you could do one more substitution here. Like I would like to do one more substitution. You could do it in this way, but to make things easier, I would like to say, like I'd like to work with a single angle of x. So this is a compound angle here. So let's just say, let another angle, let another y be x minus 0.395, which means g theta equals 10 plus 13 sine y, which is very easy for us to understand. So I want to get the minimum g theta. So if I want to find the minimum value of g theta, Okay, to get the smallest value of g, that means you can, you need to find the varying, you need to find the smallest possible answer here. So 10 is a constant, 13 is a constant, sine y is the only variable. So sine y can, the sine graph. So sine graph varies between what? 1 and -1. Am I correct? So sine graph varies between, the maximum is 1 and the minimum is -1. Okay, so I just drew it randomly. This is the proper graph, right? So it varies between 1 and -1. Okay, maximum 1, minimum -1. So if I want to find the minimum g theta value, g theta minimum, that means I need to make, so this is all in the numerators. Everyone is directly proportional to g theta, which means I need to get the smallest possible value of sine y. So the smallest possible value of sine y is -1. Okay, so sine y, the smallest figure is -1. So that's what you need to realize here. Okay, so that's what you need to realize here. So then we end up getting here. G theta minimum is 10 minus 13, which is -3. So the smallest, the minimum G theta value is -3. Okay, so that's the answer for Roman number 1. Okay, and then moving on to Roman number 2, the smallest value of theta at which this minimum occurs. So what's the theta value when you get this minimum? So how do we do that? So Roman number 2, to get the minimum. Now you know the G theta minimum occurs when what? G theta minimum occurs when your sine y becomes 1, -1, right? So it occurs when your sine y, when the sine value is becoming -1. So all you got to do is now figure out the angle. So what are the y values? What are the angles here? So sine of what? I think you can see here if I draw this, this is the sine graph that I've drawn here. So if I keep drawing the sine graph over here, you can see you get -1. So I want the smallest theta value. They want the smallest theta value. So we will take the two closest value we have to 0 and see which one is the smallest. So the first theta value is, I think, so this is a rough graph. This is 270, 3 pi over 2. Sine 3 pi over 2 is -1, and also sine -90. Sine minus pi over 2 is also -1, isn't it? Sine 3 pi over 2 is -1. According to the graph, you can check it with the cal also. And sine minus pi over 2 is also -1. So y has two candidates, minus pi over 2 and 3 pi. There are more. You could get a lot more, right? Because your graph goes further. But I took the two closest people because they want the smallest value of theta. I just, because I've used a lot of, how do you say? I need to go back to this theta. So it's better to have a few people extra, just two people to know who is exactly the closest. So who is y? Once again, y is x minus 0.395. X minus 0.395 is y. So replace it back. So then get the x answer, take the 0.395 to the other side. So x equals, at the 0.395 to minus pi over 2 and 3 pi over 2. So minus pi over 2 plus 0.395 is the first answer. And the other answer is 3 pi over 2 plus 0.395. Okay. So these are the two figures you get for x. And the next thing you do is x is 2 theta minus pi over 6. So x is 2 theta minus pi over 6. Can you see? So what goes on here? So 2 theta minus pi over 6 is x. So our task is to make theta the subject. So if your task is to make theta the subject, the pi over 6 should go to the other side as a plus, and 2 should go as a division. I hope this is clear to you all because this is a little bit complex. Minus pi over 2 plus 0.395. The minus pi over 6 comes here as plus pi over 6, and then finally to make theta the subject, the whole thing divides by 2. Okay, so this is the first answer. Next one, 3 pi over 2. Same story for the other guy. 3 pi over 2 plus 0.395. You add the pi over 6 and divide by 2. You add pi over 6 and you divide the whole thing by 2. And now take the smallest. I think they want the smallest theta at which it occurs, right? Let's find the smallest value of theta at which the minimum occurs. So then from these two, we'll check which one is the closest. So then we'll take the first one, minus pi over 2, minus pi over 2 plus 0.395 plus pi over 6 minus pi over plus 0.395 plus pi over 6 over whole thing divided by 2, right? So this is the first answer. So this gives me minus. So it's a negative figure. Minus 0.32. Minus 0.32. So I think that will not work out, right? Minus 0.326. Minus 0.326. Okay, so that does not work out. So let's try the other guy. Okay, so this one. 3 pi over 2, right? So the only thing that changes here is 3 pi over 2. So I'll erase the minus, and 3 pi over 2 plus 0.395 plus pi over 6 divided by 2 equals 2.815. 2.85. So this looks good. This is the positive figure, right? 2.815. 2.81549. So find the smallest positive value of theta. That's what this is. The smallest value of theta at which the minimum occurs. So the smallest value of theta, you should take a positive figure. So theta is 2.82. So the smallest theta value is 2.82. Okay, so if there are any questions about this, please do let me know. I would be happy to answer. Okay, so then the next one, part C. Part C, find the range of h beta equals 10 minus 12 sine beta minus 5 cos beta whole thing square. So again, obviously we'll need to, replace, 12 sine x minus 5 cos x is, so as you can see, 12 sine x minus 5 cos x is 13 sine x minus 0.395. So this is 13 sine x minus 0.395. So remember, it's the whole thing square. So 12 sine beta minus 5 cos beta. So it's not x here, it should be beta. Remember, this should be beta because it's not sine x. It's now sine beta. So it gives you 13 sine beta minus 0.395, right? The whole thing is the same, just x replaced by beta. So then they want the range. Okay, they want to find the range. Okay, let's simplify h beta. Range means a set of possible y values. So 13 square is 169. Sine square beta minus 0.395. So range is a set of possible y values. So basically you could again replace h beta is, so you could say 10 minus 169 sine square. So just put some value here, sine square. So we use x, we'll say sine square a, where a is beta minus 0.395, the angle. So I think having a simple angle is very easy for us to understand because we can work with sine x cos x, right? Sine a cos a, it's very easy for us. So sine square, so you just need to find the range, the set of possible y values. So you know the sine graph, once again, the sine graph maximum is at 1, minimum is at minus 1. However, now we are working with sine square a, which means we square our function. So when you're squaring, I think you can see the maximum value 1, squaring of positive 1 does not make any effects. So squaring of positive 1 is 1. The positive peak does not change. However, when you square the negative 1, so I think you can see the below peak is negative 1. So if you do square the negative peak, I think you can see that it will become plus 1, isn't it? So when you do the sine square function, the positive peaks are okay. The positive peak doesn't change, but the negative peak actually goes up. The negative peak is coming up. I mean, you get something like this. I hope you guys can see that your sine square function, the graph will be, because it's a square function, you will not have any negative figure. Square functions are always positive, right? So these negative figures will all become positive. Your graph will actually, the entire graph will be moving, above the x-axis. So then what you could see here is the maximum value you could get for sine square is 1, and the minimum you get for sine square is 0. Okay, so can you see the smallest you get is going to be 0, not minus 1 now. It's not going to be minus 1 because minus 1 when you square it becomes plus 1 because it's a square function here. So then the range, obviously get the range. One thing you could do is to put sine a is sine square a is 1. So when a is 1, that gives you 10 minus 169, that gives you minus 159. And then the other one, so this is when sine square a is 1. So that's the maximum you get for maximum sine square is 1. Minimum value of sine square is 0. You don't reach -1. Be very careful. So h beta equal 10 minus 169 sine square. The smallest value is 0, which gives you 10 minus 0, 10. So range of h beta is going to be greater than or equal 10 and lesser than or equal to negative 159. Sorry, I'm sorry. Greater than or equal minus 159. I'm sorry. And smaller than or equal to 10. Okay, sorry. So negative 159 should be greater than, h beta is negative minus 159 and lesser than or equal to positive 10. So this should be your final answer. Okay.